For our third lesson in our matter unit, we're actually going to take what we know about properties of matter and apply it to studying minerals. And minerals make up a large portion of our Earth. And when we talk about minerals, we've basically got a few different characteristics that all minerals share. And to define a mineral, we say that a mineral is a naturally occurring solid substance with a specific chemical makeup. And basically, that means that naturally occurring means they're found in nature. It's not something that's man-made. A solid, of course, is just a state of matter, meaning that in its natural form, if we went outside and found it, it would be a solid. It wouldn't be a liquid or a gas. And a specific chemical makeup means that this entire mineral, for instance, if we have quartz, this piece of quartz is chemically alike throughout it, meaning one molecule of quartz is like another molecule. Minerals basically are just the natural, non-living solid crystals that make up rocks. And we'll talk more about rocks later in the unit, but rocks can be made of many kinds of minerals, but a mineral in and of itself will always be basically the same substance. So when we talk about characteristics of minerals, we've said they're non-living, we've said they're solids, they're naturally occurring or found in nature, they have a specific chemical makeup, and the last thing on there that kind of ties in with the chemical makeup is a specific crystalline structure. And we'll look at some examples of mineral crystals in class, but essentially the same types of minerals will have the same shape, the same type of crystals. So that helps us in identifying them. Now, scientists that study rocks and minerals are called geologists, and geologists can identify minerals based on their physical properties. And based on these properties, they can also classify the minerals. And there's a variety of different properties that we look at specifically with minerals to help us identify them, to help us classify them. And these are things like color, which you can usually observe simply by looking at it. Luster, which describes how shiny a mineral is. Hardness, density, which is how tightly packed together the molecules in the mineral are, crystalline structure, which we talked about, and streak. Now, when we measure mineral hardness, they actually have come up with scales to help us determine the hardness of minerals, and basically we do that by comparing one mineral to another. And one of the commonly used hardness scales is called Mohs hardness scale, and it just takes 10 fairly common minerals and rates them based on whether one is harder than another or softer than the other. And the way to test that is by scratching a mineral. For instance, if I can take a piece of talc and scratch it with a piece of calcite, that tells me that the calcite is the harder of the two minerals. And Mohs hardness scale actually starts with number 1 on the scale, which is talc, which is a very, very soft mineral. You can actually scratch it with your fingernail. And it goes all the way up to diamond, which is one of the hardest minerals known to man. And everything in between kind of gives us basically some base points that we can use to compare the hardness of other minerals. Some common tests that we can do with a mineral, in addition to trying it with known mineral samples to scratch it, is using things like our fingernail, copper pennies, iron nails, steel knife. And if we look at this example of Mohs hardness scale, it actually gives us some different tests that we can do. A mineral with a hardness of 1, for example, or a hardness of 2, we could actually just scratch simply with our fingernail. Something like calcite with a hardness of 3, we could scratch with a copper coin. Something with a hardness of maybe 4 or 5, you could scratch with a knife. But then you get down to the harder elements, even things like diamonds and rubies and sapphires, that would be the corundum. Those can actually scratch all of these other minerals, but they can even scratch things like glass. So you could use that as a test once you get to the higher end of the hardness scale.